Okay, we're going to start looking at section 1.2, which is about measuring and constructing segments. There's a lot of terms, once again. Always highly recommend that maybe you make flashcards to help you memorize a lot of the terms, postulates, axioms, those types of things that we will actually begin to um, learn and discuss throughout, not just chapter 1, but throughout the entire book. So it's always great to remember them because stuff that you see in chapter 1, postulates, you're going to have to use again in chapter 2, and chapter 3, and chapter 4. So if you forget stuff from chapter 1, um, when we start doing more proofs in chapters 2, 3, 4, and so on, it'll become much more difficult. So let's start off and take a look at some vocabulary. The first term right here is what we call a postulate. That is a rule that is accepted without proof. Okay, so if you're going to read about several postulates um, throughout the course, and those are just things that you accept without proof. Now, why should I accept it without proof? One, because it's always going to be true. Okay, so that's why uh, you're able to just accept it without um, any other evidence to back up that statement. The next one right here, let's take a look, is axiom. An axiom is a rule that is accepted without proof as well. So those two, uh, they pretty much mean the same thing, different words. Let's go ahead and move down. We talk about a coordinate. Uh, you guys should be familiar with coordinates, having done graphing already. So it's a real number that corresponds with a point, and we use points as far as x comma y, right? And make sure you use parentheses. If you don't have parentheses in your homework and on the test, it'll be considered wrong because the only way I know that it's a point and not just two numbers is the fact that you have parentheses in it. The distance is the absolute value of the difference of the coordinates of A and B. So if I want to figure out the distance between 2 points on a number line, well, you'll take whatever A is and B, you'll subtract them and take the absolute value of it. Now we also have the distance formula, and that's when we use that when we actually have two coordinates and we want to find the distance between them. And that's something that you should have seen in Algebra 1. We'll take a look at it again a little bit later in this lesson as well. Next up, let's look at this term called a construction. So constructions is a geometric drawing that uses a limited set of tools, usually a compass and a ruler. One of the things that you're going to have to develop or figure out is how do I copy angles? How do I copy segments? A bisecting angle. And those things are all, we'll do that through constructions. Now we might not be able to do that together uh, since we're not in class, but if you do have a compass and a ruler, you will see that in the book, um, there are diagrams and examples that show you, hey, how do I construct a segment? How do I copy them? You know, it's not just let me get a piece of paper and trace over the book. And it doesn't work. That's not what they're asking for. There's specific tools that we could use to help us construct and copy segments and angles, particularly segments right now in this section. Congruent segments. This right here are segments that have the same length. Now, for some, you may think it's the same thing as equal. It is, however, we don't use the equal sign when we don't know if we only use it, or how about this? We only use the equal sign typically when we're given actual numbers. If I know one segment is 5 and the next segment is also 5, then I can go ahead and use the equal sign. But if all I know is that this segment right here is equal to this segment down here, or congruent, they're the same length, then we just say that they are congruent. So here's our first postulate. we have the ruler postulate, and it is 1.1. You don't necessarily need to know the numbers of these postulates. Just make sure you know the names of them. And what all this is saying is that the points on a line can be matched one-to-one with real numbers. The real number that corresponds to a point is the coordinate of the point. So on a ruler, obviously we have different measurements on there, right? If it's we could talk about it in inches. So one point could be on inch 1, and that'll be 1. Another point could be on, let's say, like inch 5. And then so if one point is on 1, another point is on 5, they're saying, well, let's go ahead and we could find the distance between the two by subtracting the two numbers and then taking the absolute value. And then those points can be matched up with real numbers. All right. So over here, what you'll notice is we have segment AB and segment CD. Now I know that these two are congruent because on the actual image itself, you can see right here, and I'll highlight it in red. There's that symbol. That little tick mark tells us that those two segments are congruent. Now, if segments are congruent, that means they are equal in length. However, once again, because they don't tell me that like segment AB happens to be like 10 and segment CD is 10, we're not going to use the equal sign. Okay, what we'll go ahead and see right here is say that segment AB is congruent to segment CD. If we actually had numbers, then we can go ahead and say that they are equal. And that part is especially important when it comes down to proofs, when we start dealing with proofs later on. So once again, we know that these two segments are congruent because of this little tick mark that happens to be on each segment. The segment addition postulate. Now this one is a big one. You're going to see this used so many times, especially proofs later on. But simply put, they're saying this. Look, if I take segment AB and I highlighted that in blue, I take segment BC right there in red. If I add those two small segments together, it will equal the big segment of AC. I highlighted that in green. So by taking two segments together, adding them up, that'll get me the big one. That is the segment addition postulate. Now I stress this because you have to be able to know how to come up with the equation. And so once again, if you take AB plus BC, that's equal to AC. Set it up on your homework and then solve to find the missing piece. Okay, that's why I'm saying it's important. When I want to see your work for this, I want to see, can you set up the equation, and then can you go ahead and solve for whatever segment that is they're asking you for. So if they said like AB is 5, BC is unknown, they want you to solve for that, and AC is, let's say, is 12. I set up my equation first using the segment addition postulate. Then let's plug things in. AB is 5. BC is unknown, so we'll go ahead and just leave it at BC. And then we have AC is equal to 12. You can go ahead to get BC by itself. We subtract 5 to both sides, and BC is equal to 7. That is how I want you guys to do your homework. Okay, so don't just mentally say, oh, I already know what BC is. BC is 7 because 5 plus 7 equals 12. Well, I don't know that, and you have to show that in your work. And like I said, later on when we do proofs, the students that have a hard time with it are the ones that are not creating their equations and setting it up correctly. All right, let's take a look at some of the exercises that we can do together. The first one right here, if we take a look at number 1, it says plot the points in a coordinate plane and determine whether A, B, and C, D are congruent. Now, the easiest way to determine if these two segments are congruent, actually instead of graphing, it would be best if you use the distance formula. And hopefully you guys remember what the distance formula is. Give you a few seconds to think about it. And if you have it memorized, that's awesome. All right, and so the distance formula is x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And you're going to have to plug in the points. Use the distance formula twice actually because we have two segments here in order to figure out if they're congruent. Now, how do I know which one is x1 and y1 and x2 and y2? It really doesn't matter, but what would be important and very helpful for you is if you take a look at this right here, maybe possibly label things to begin with. Okay, so what I tend to do is I'll go ahead, we'll say this is x1, y1, and this point B will be x2, y2. Does it matter? No. What you can't do is interchange, let's say -5 is x1, and then say that this right here is y2. That's something you cannot do. And then remember, you're going to plug things into the equation, see what you get for the distance. You'll do the same thing for segment CD, plug things in, and then see if AB is equal to CD. And if they are, that means they are congruent. The big thing right here, let's go drop down to number 4. They are asking us, let's find segment VW. Okay, so VW is this piece right here that we don't know. Once again, I want you to use segment addition postulate. So start off, we could say VW plus WU is equal to VU. Always start off by writing down the equation first, and then after that we can go ahead and substitute things in. We don't know what VW is, so we can go ahead and just leave that right here. VW plus WU is 8. That's equal to 31. So I constantly urge you, make sure in your homework, in order to get full credit, you must have your segment addition postulate and make sure you write that down first. So we'll go ahead and subtract 8 to both sides, and then you'll get your answer. And then this right here will end up being 27. That is segment VU. Take a look at number 5. So once again, setting things up, we have segment UV plus segment VW is equal to UW. We'll substitute things in. UV is 6 plus VW. We'll go ahead. That's what we're solving for. We'll leave that there. If you want, you could substitute that as X. But since we know what segment it is, it's probably helpful to label it as what you see there. And then we'll go ahead and plug in 18 for UW. We'll subtract 6 to both sides. And VW right here is equal to 12. So once again, always start off by setting up your equation and then solving it out. Lastly, let's take a look at number 7. Good word problem. You might see something like this on a test or a quiz. It says a bookstore and a movie theater are 6 kilometers apart along the same street. A florist is located between the bookstore. Now hopefully you realize that if we talk about something that is between, it is inside of the two. All right, so if I have right here, what they're saying is, I would always start off with a diagram. I think that's always very helpful. And we have, I'll go ahead and label this first part B for bookstore. Right, it says, and then there's a movie theater also that's 6 kilometers apart. So let's go ahead. I can label this right here T for theater, okay, or M for movie. And so somewhere in between would be the florist. Now we have to kind of think, well, where should the florist be? Where is it close? What is it closer to? It says the florist is actually 2.5 kilometers from the theater. So I would go ahead and safe to say that possibly something right here, that would be where the florist is. And we could say that this happens to be 2.5. In the beginning, it says that the distance from the bookstore to the theater right here happens to be 6 kilometers. So we're trying to say how far is the bookstore from the florist? That is the $1,000,000 question. And so once again, let's set things up. Bookstore to florist plus florist to theater is equal to bookstore to theater. So we'll go ahead and plug things in. Bookstore to florist is unknown, but florist to theater is 2.5 kilometers, and the bookstore to the theater is 6 kilometers. We can go ahead and solve this out now and figure out by subtracting 2.5 to both sides that the bookstore to the florist happens to be 3.5 and then kilometers. I would recommend always to put the unit of measure. That is also another important skill for you guys to work on and remember. All right, that right there is section 1.2.